In this episode of Hot Hardware's 2.5 Geeks, the future of AI in your pocket, with a very special guest from Qualcomm. Next. That was great. we are smooth, baby. Hey, it's Dave Altavilla for Hot Hardware. Welcome to yet another fine episode of Hot Hardware's 2.5 Geeks live stream. We are back from the interwebs. It's been a couple of weeks, but we've been digesting a lot, learning a lot, and immersed in AI for sure. With me, as always, is the incomparable and effervescent Marco Chiappetta. How you doing, buddy?
How's it going, everybody? I'm good.
And Chris Getting is with us as well.
Hey,
Chris
how's it going?
Gonna turn the knobs and dials in his glamorous way. But more importantly, we have a very special guest from Qualcomm with us today, Joseph Soriaga. Welcome to the stream. Welcome to 2.5 Geeks. It's great to have you with us, pal.
Hey, great to be here. Thanks for having me. I'm looking forward to chatting with you about all these things.
All the good stuff. Absolutely. And Joseph is Senior Director of AI Technology at Qualcomm, AI research specifically. And so generally speaking, Joseph's a really smart guy. So let's start there. But Joseph, tell us a little bit about your purview at Qualcomm, what you're charged with, and I guess what gets you up in the morning out in sunny San Diego.
Oh yeah, sure. So first is I'm smart, but I work with a lot of much smarter people. So that's a great thing to help me get to a position like this and talk to you about technology today. AI research. Our group has a large like sub-organization within it, looking at, say, systems related and engineering and development design, where we look at a lot of the technology in AI and machine learning, and also how we can develop it further. But then we want to put it in a system and make sure that the end goal of what the system was designed for also is improved beyond, significantly beyond where it is today. And that's how we kind of distinguish where our group is relative to just a little bit more open-ended AI research. Now,
Gotcha.
And then within my role in the group, so I have the benefit of working with a lot of our great talent, and I hope to kind of understand what's going on, help steer the strategy, help to put the resources and decide what we should be going after and how we should pivot and so forth. And it's always an amazing thing, because every day since I've joined AI research, it's always been changing, and probably this year more than ever, with just the amount that is impacted even just regular folks. So it's always an exciting thing. I might want to just say one other thing about like the purview. I have been with Qualcomm for quite a while, probably 18 years now, and I have started with research from the beginning. So I came out of school and joined what was corporate R&D at the time. There's a lot of wireless focus, but also applications in multimedia and computing, mobile computing. And so it was something that has been keeping me up every day. When you ask that, we have always been charged with looking at research, but then seeing how we can realize it in today's systems. And it's always been like an amazing opportunity that the company itself invests a lot in research, but then they also can scale up and look to bring it to these applications. And you really don't understand if you can do it until you build it out. So we learn so many little things that we don't need to belabor everyone to know it, but it's really important. And just that process, even from the very first project I was with at Qualcomm, has always been something to keep me going within research at the company. So.
Nice. Yeah. If you build it, they will come, as they say. And my friend, 18 years with Qualcomm, you must have started when you were 12 or something.
Yeah.
Because that's a long time. That's a long time.
And very impressive.
How long has Qualcomm been I guess, engaged in AI research and development. I think, AI has been around for a long time, but I guess obviously had, a breakthrough moment here more recently. But you guys have been pioneering in this space for quite a while, right?
Yeah, yeah. It has been so within R&D. We had activities even predating AlexNet, but that's probably the big inflection point where we just a lot of shift into deep learning on research, and then very quickly after, even the mobile computing platform started taking in workloads on the GPU, for instance, to show that we could do image classification for that was in the state of the art papers also on device. So that's over a decade. The company's been active here. It's always a moving target, and it's always a lot of new innovations come. So classification, ImageNet is there was a decade anniversary at NERPS last year, and now we're in generative AI, and it's a very different. It's just like an amazing AlexNet moment, is what people say, where suddenly what you didn't think could happen is happening, and the capabilities are like emerging. And there's a lot of activity onto where can we put it, how ubiquitous can we make it, and then how can we integrate it into a lot of our current activities, our platform, our business, our partnerships. It's quite a lot of things happening. So.
Yeah. Great stuff for sure. Marco, I know we have a bunch of questions strung up for poor Joseph here. We're going to pepper him real good, but why don't we set some ground rules here with the chat and let you do your bouncer thing, and then we'll dive in. And I know you can take the first couple. How's that?
Sure, sounds good. So anybody, if you have questions, whether you're on Facebook, YouTube, Twitch, whatever platform, throw them into the chat, and we will moderate as as we can. Obviously, there are some questions Joseph's not going to be able to answer. He's not going to disclose any future product plans. Not going to get himself in trouble, but we'll do our best to get any relevant questions answered. And I think let's start out with a real simple one, Joseph, because I think lots of folks don't understand how much AI may have already impacted their user experience on mobile devices. Can you talk about some of the situations where AI is already being used, and perhaps some of the future use cases that are on the horizon?
Certainly. Maybe the ones that are most ubiquitous are around perceptual applications. So within your mobile device, there's a lot of speech. There's a lot of speech detection, speech denoising, and things of that related matter. There's also, as you move up perception, there's automatic speech recognition, in some cases even text-to-speech. Within that, a lot of that has gone into deep learning end-to-end type of solutions, and that's kind of where the state of the art has moved. Similarly, on the camera side, I think pretty much everyone knows like AI camera enhancements now. It's kind of table stakes for putting out a phone, and that is a lot of amazing things happening under in the pipeline, from understanding what's in the picture, understanding where to apply what kind of optimizations into enhancing the photo, that have been just baked in to a point where you may not even see it. And I think that's usually the best thing, is if you don't really see that it's there. It's just happening so quickly and so effectively. Those are probably the things that are happening today. And then the moving forward, this ability that we're seeing with generative AI is maybe taking it to another level, where I think like reasoning and interaction can probably be a lot more accurate and natural than it has been. I think it's somewhat a little bit imperfect when we do, say, like a voice interaction with our phones or so forth. And people are very good to engineer how you should interact to make sure that we have a very good, efficient use of that application. But now you see how things are in the cloud, where you can be a bit inaccurate in what you ask, and it will figure out exactly what it is that maybe is answering your root question. And we're looking to see, are those the kinds of things that we can bring to the edge, make it more ubiquitous, put it within the device to understand the context, excuse me, within the device, because you have a lot of personal content, you have a lot of documents. Maybe these are things that are just more effective for you to search, or there's privacy reason you want to keep it. And so that's where we see that potentially we could have a lot more benefits in this next level of AI.
Yeah.
Yeah,
So I guess
it's great.
so one thing, especially when you have those voice
Yeah.
assistants and you see people interacting with them and you hear them and they're still seemingly used to speaking to them in a very robotic manner, does that actually help with the understanding of these AI models, or is just speaking naturally a more effective way to go to get the results you want as a user with where technology is now?
Yeah, I mean, it's not starting to get into a little speculation, but I would think that we don't want to be trained to be robotic to be able to interface with our applications. And the more natural that things are, even maybe the more, the better the interactions. Not just like the interactions themselves, but we might actually start depending on them to do more for us, because the interface is a lot more natural for us to be able to ask different things, or try to get more use cases into them. But right
More
now,
context.
yeah, exactly. Yeah.
Nice.
But yeah, that's how things are evolving. I wanted to make one quick point, like the what I said earlier about how we're working in like somewhat perceptual and some like waveform or pixel related domains. It's interesting when we were looking at generative AI on device, the inference speed that we need to execute certain things on is an important thing to keep in mind. So when we look at, say, camera applications or video applications, there's high resolution, but we're trying to do things 60 times a second or more, maybe 100 times a second. And then we come to generative AI, and now you just have to do it within a few times a second. So maybe you can do something that's 100 times bigger, and then you have the same engine kind of behind it all, being able to do these things that are very fast, very perceptive, or a little bit slower, but a lot more cognitive, or a lot more capable. So that's how we're optimistic about being able to put all these things together in an edge device.
We have a couple of demos coming too, by the way, folks. So stay tuned for that. This will be fun. They're going to be live, and that the live demo is always an interesting time, right? So stay tuned for that. Joseph, when you think about AI at the edge, and when you think about the application in a smartphone or a device that's sub 10 watts, maybe sub 7 watts, what are some of the challenges with that? What sort of basic requirements do all researchers in your field, where it needs to be efficient to have it function on device, what are you challenged with? What are the obstacles you need to overcome? Because it seems like latency and bandwidth and speed is not in your favor, because you don't want to have to connect to the cloud. You want to run this on device, and so you have some significant hurdles there to get over. So I just wanted to get your thoughts on that.
Oh, it's always fun to have big challenges ahead. So I think that most people have already a good feel that you have limited compute, you have limited memory. Form factor also, like you said, put you at a power class because you don't want it to get too hot or so. Yeah, we have to wrestle with these, of course, and that's where there are various things that we would look at. Within compute, for instance, can we make the models smaller? This is like the very first natural thing that comes to mind. So there's something that may come out of a paper, very effective, really amazing results. Has it really been distilled? Has it been quantized? Has it been compressed? These are the things that we look to do when we think about deploying them and seeing them where they're effective. So in these things like compute and memory, it's very natural to think about like the representations of the numbers themselves, the weights and activations and the calculations you're doing. And quantization is an important focus for us because from a compute standpoint, just less bits means there's less area, there's less logic in making each of these calculations for each neuron. And then if we go to thinking about like the memory movement that happens, if we have to move activations from the compute onto the RAM or move the weights the same way off and on the chip, then it benefits again there to look at what's the smallest like number representation that we can use. Now that affects the model without necessarily changing the architecture, just changing the weights. We can get a little bit smarter too if we know like the application that we're working in, and that's where we can look to think, okay, if it's in a mobile device, there's maybe a certain context or a certain domain in which it's probably going to be used most of the time, if not all the time. Can we distill that down to focus on the application where it's going to be intended instead of having a general use model kind of in the edge? And that can afford us another, increase, significant increase in power savings or compute or latency. So that involves like another step in thinking deeper about like the machine learning behind the solution and the application. But it's worth the investment in that if you really want to make something ubiquitous and used all the time.
Interesting.
Then we generally, the last piece is, does it even fit in what you have and not run temperature? But then, the most important thing is for, the extreme that Qualcomm covers is mobile. So you're not always plugged in even. So we have to be very frugal with what we do with our power. And so, for instance, in number formats, it's not necessarily enough to be 8-bit. It's important to be 8-bit integer if we really want to have the best power efficiency on device. And that's something that, nominally when the interactions are not so frequent, can be taken for granted a bit. People say, oh, it works great. I'm very happy with it already. Now, if you start running like a video or a camera, something that's continuous or audio is always listening, that's where it's going to be a lot more significant that you pay attention to these things. And we put a lot of kind of investment in understanding what's the best approaches, how much can we gain from them, and then how do we even bring them into the work with our partner groups in AI software and hardware to see if we can put them in the commercial stack, Qualcomm's AI stack or their AI studio.
Yeah. I mean, that's you're talking about some wild stuff. I mean, I'm gonna back up on some of your lingo here because it's interesting. But
probably too much shorthand and
no. It's all good. It's all good. So you need to be aware of the context or the device that it's running on, and using that context helps you optimize the model a little bit. But you talked about neurons and quantization, which sounds like, for a lot of folks, I'm sure it sounds like something out of Star Trek, but give us maybe the basic, I guess, understanding of what quantization is.
Sure.
Yeah, would be good.
Okay. Let me start by saying that so maybe let me tell me if I'm going too far back, but if I break down these say neural net calculations, there'll be a series of, say, tensor, basically like matrix or vector or higher dimensional tensor multiplications. So you're really just looking at addition, multiplication, accumulation, and it comes down to what are the numbers in these matrices that were trained through a lot of the machine learning and the that amazing stuff that we've done with deep learning that dictate the weights that go in that. And then when we do the calculation, there's this forward passive, okay, we have our input and then we're going to infer our final task by doing all these, basically these multiply, add, accumulate operations, and then some nonlinear functions like like very low, like clipping and linear, or some other tangent type, some nonlinearities in there. And as we go through and we do these fundamental calculations, and then a lot of them, we're talking about, sometimes tens of millions of tops, or even beyond that. These numbers, you're doing so many of them that how you represent that number is important for reducing that complexity in the calculation, or reducing the power consumption in the calculation. So as an example, if I took a model that was FP32 floating point and a 32-bit floating point, and then I went through the math of doing that, and then I compared that with going to 8-bit integer, which is 4 times smaller in bit width. That's at least, these benefits in energy are quadratic, so that's at least 16 times lower energy efficiency. But then on top of that, I'm in an integer math, so my area and further computation is better than floating point. So you can start to feel like, okay, if I'm going to be doing millions or even billions of calculations, that 16-fold reduction is going to be a big deal. And just from the quantization alone, and then going forward, like I mentioned, there are other things that you'd want to do to the network if you could understand how it's going to be used, and then start distilling it to the target application, or fine-tuning it, pruning weights that are not going to be used very often. That kind of second level of optimization can come in. And overall, this is where we look to bring it to the edge, look to work within that compute budget that we have, or that memory budget, or that power budget. Yeah.
This is from a couple years ago when I was at ARM, and they were talking about weight pruning and that kind of stuff with the NPU they had at the time.
Interesting.
Yeah.
Yeah, there you go.
Our if you go to Qualcomm AI Research, we have also AI model efficiency toolkit, and there's a lot of great kind of details as to how you, like, what you want to do, and then we tie it into tooling so that you can go and, if you have your deep learning network you want to try it on, you can bring in the image. You can go to the open source, put it into your training pipeline, and try some things out with post-training quantization, or quantization. I can talk more about exactly what these things are, but yeah, there's a lot of tools that come behind getting the networks to be efficient in low bit width.
Yeah, we'll circle back on that, because I actually wanted to dig into that a little bit. But Marco, what do we have? We had a couple of questions come in from the chat, and then I know you've got a couple more on your backlog as well.
Yeah, most of the questions that have come in on chat are actually related, and we'll save those they'll be more pertinent during the demo time. So we'll save those up so far. Joseph, you've already actually touched on this, but as a nerd, right? You hear the term int8 or integer 8 versus FP8, or even FP32, and you hear floating point calculations. You inherently think the floating point stuff is going to be significantly more accurate. But through your quantization techniques, with a number of models, you've shown that int8 or even int4 can be nearly as accurate. We're talking, fractional differences here. Can you talk about, what kind of techniques are used to get sort of the accuracy to be so good using int8 or even int4?
Yeah, certainly. So some of it is just at a high level, is that the distribution of the data may not need such a wide precision. So if you figure out where your range is and what your scale should be, you already can address like some very important, first level matching with the distribution that's going through the neural network. Now, within, maybe I'll just talk within AI model efficiency toolkit, because you can always look it up afterward. Within that, there are like let's say a range of tools. We have this gradient at which you can start off, and you're just given a model, and you want to convert it to integer weights, and you don't have any data. Maybe you have a little bit of data to understand operationally what it's going to be like and validate it, but otherwise you just want to take the model and then deploy it in integer. And then that's on say like the lightest touch aspect. And then on the most kind of most comprehensive solution is you could go back, and if you have the training pipeline and the training data, you can optimize the weights in the network, knowing how quantization would be affecting the forward pass of the network, and then find the better integer weights that would correspond to the performance that you want. And that's better matched to what you want to do when you actually deploy it. So within this, in some cases you may not need, full-blown retraining. In some cases you may. And then somewhere in between, we have various different things where you might have a large data set that's not labeled. It's not necessarily a training pipeline, but you can use that enough to optimize weights, because it just gives you more clues and gives you more signal in which you could minimize loss function. Now, 8-bit is like one aspect. Just to get even nerdier on you, there's what do you do on the weights? You can make them 8-bit. What do you do on activations? You can also make them 8-bit. You can make them 16-bit too, and that actually would make your precision even better, and then address a lot of models pretty much that can come from FP16 with some calibration, understand how to scale your 16-bit representation to match it. And then we can even go smaller. So like 8-bit integer was, even last year we were doing at Snapdragon Tech Summit, and we had some papers leading into that beforehand. We were doing research on how should you build quantization tools towards 4-bit weights and in 4-bit activation. And so you can even take it further, and there are some algorithms that we also have, like Ada-Round or quantization aware training, that allow us to even push all the way down to 4-bit weights. And with 4-bit activation, it is a bit challenging. I think activations are probably better with like 8-bit or larger. But with 4-bit weight, where you may see these just publicly in different blogs and so forth. Large language models are being pushed into 4-bit weights because of how much bandwidth is needed to move weights back and forth when generating each of these tokens. So it's just like a very natural thing that it's very beneficial, and so it's gradually we move in that direction, and we keep pushing to see how much lower can we make things, or how much more variability can we put in the quantization, so that we have kind of the tightest envelope to low power and low compute.
Yeah, that's an important consideration. As tech nerds and hardware guys, we often think it's the engineers building the chips, making the chips more efficient to bring that power down. But with these AI models, it's also doing this quantization work to make everything more portable and more efficient to compute on the chips. It's very much a synergy with the hardware and software going on here. Can you just I'm going to back way up again for a second. Can you give just some background on what sort of applications are perhaps already using Int8 on mobile devices?
Oh, sure. So what I mentioned before, these camera applications, speech applications, voice denoising, speech denoising or speech detection. Yeah, those are networks that are using Int8. I would say that there's every incentive to push these down to 4-bit weight or even lower on activation too.
Is there a limit to how far you can go down? 2-bit, 1-bit?
I mean, you can't go below 1. So that's the fundamental limit. Yeah. I mean, so it's always an interesting research topic coming back it's like almost periodic. Can you do a bit network? Because people really like bits because it's just XORs. There's such a draw to that it seems to come back. And but I would say we're not there yet, but it's certainly like we always want to get smaller. It's like everything. We always want to see how far we can push the envelope. But right now, I think where things are, 4-bit, maybe 3-bit. Some clever quantization and further like effective reduction of the bit width is what things are going. What's interesting is like we still want to be able to keep that compute benefit. So keeping a uniform number grid like an integer grid is still important to get that compute benefit. There was, I think when you asked earlier, there was one other thing I had in mind to come back to on the things that anyway, maybe maybe it'll come up again. So.
No worries. There's been some chatter, I think, out there that FP16 or other floating point, FP8, floating point math might be a substitute for int8 or integer math. What are your thoughts there? It seems to me like it wouldn't necessarily provide a better accuracy and certainly not lower power, but just wanted to get your thoughts there since you're the expert on that stuff.
Sure. Yeah, we actually, so people can look this up. We had a paper last year in a webinar on FP8 versus int8, among other things in quantization. And then we had a white paper released earlier this year, really looking hard at taking that paper, having a wider set of benchmark, and also looking at the hardware implications of building these things out. Maybe the short answer is if you really focus on inference, most, like, the compute is different between floating point and integer, and it's more streamlined with integer. So somewhere along the way, you will be sensitive to compute, and it will be important to do the most efficient, multiplication, addition, accumulation that you can do. Now, if you're on the training side, for instance, and bandwidth is really the issue, at some level, 8 bits is 8 bits, and if it's not compute dominated, people might take a shortcut and say, okay, let's just get this part out, and this takes care of most of our issue because we were bandwidth limited. But if it's a completely edge inference, we can't leave anything behind, and so we want to be able to say, okay, that whenever we do have compute heavy workloads, like a lot of pixel processing, we have, say, super resolution as an example. There's a lot of compute in that to make sure that we can upscale an image and then produce new pixels to have a higher resolution image that's perceptually pleasing and consistent with the image. That's something that the better the compute, the more important it will be for power, for latency, and so forth. So that's where we took it actually with an open mind, because there's a lot of push in that direction. You have to look at this, and when we did that hardware software hardware implementation trade-off, that's where it became important. Otherwise, nominally, when we look at accuracy, they're both 8 bits, and one representation versus another one, you'll have to do some tricks to get your distribution to kind of fit, and those are not necessarily better for one versus the other. So from an accuracy standpoint, we would see we could compete between these two methods. In some cases, you might even do better on integer. In some cases, you might do better on FP8. It's just a matter of how much you're investing in retraining or fine-tuning, or what is the distribution, what is the model you're using. But the big separator was more on this this implementation and the focus on inference. So that's where we were.
There you go. There's a good pictorial for folks that want to kind of conceptualize this a little bit more cleanly. Compression, quantization, and compilation. So that's kind of the training and optimization flow, if you will, right, Joseph? We have that.
I'm glad you guys can just bring this up. It means that it's still out there and accessible, and it's at the top of the search ranking.
There you go. Yeah. So that kind of shows what it's all about, kind of a flow, if you will.
Yeah, absolutely.
And
I didn't talk much about compilation, but that's a really important aspect too. I've probably been very heavy on quantization. So compilation is the kind of the stage at which we have our hardware components and accelerators, if you will, that will super optimize to make these certain computations. And we have our network that we're going to break down and see how do we map them to these computation units. And there's a lot behind that, like, breaking that down is, some people call that tiling, understanding how you put different each of these units to be computed. That's like a placement kind of problem. And then understanding what's the order in which you should do things so that you have the tightest latency. You don't have any bubbles in your timeline or idle processing units. That's like a scheduling consideration. And then on top of that, when we're doing all this, we also want to make sure that we minimize the memory movement back and forth between the chip. Like if there's certain order of operations that we can do, maybe we should do that instead, because in the end, our end goal is really inference per second or power versus inference per second. And we want to make sure that we do the right thing in all of those. So quantization makes the problem smaller, so to speak, and then we still have a problem of like, how do we run it and how do we accelerate it? And that's where compilation comes in. And a lot of really amazing things that are under the hood there. That, I could get very nerdy on you guys for that.
Yeah, that's good. We like the nerd.
So what kind of considerations do you make when you're deciding whether to put a workload on the CPU, on the GPU, or whether you need a dedicated, AI processor?
Neural engine,
and the different kinds of models that respond better to each of those hardware decisions?
Yeah, that's a good question. Probably GPU and CPU are just from a programmability standpoint, just the most open. So sometimes the initial lure of that or the onboarding is because of that. From our standpoint, we do put a lot of focus on like the int accelerator, because that is where we see where is the frontier of what we can do at the edge, because we have this accelerator that's really tuned to doing machine learning type of execution. Whereas CPU is general purpose, the GPU is rendering first, and then it comes in and has a lot of operations that are very useful for machine learning. But from a research standpoint, I mean, a lot of them have their strengths, and at the end of the day, though, from our standpoint, we look at this, like quantization, for instance. We really push it down, where we're working on a processor that can take advantage of the fact that it doesn't have to compute as much because the representation is smaller. So yeah, that's a question.
That's a tough one too. Why don't you guys want to light up a couple of demos and let poor Joseph breathe a little bit here? Might be a good idea. So let's Joseph, we have two demos. We have stable diffusion live on a handset, and we have an int4 super resolution demo, I think. Why don't we start, because we probably have a fair number of gamers in our audience. Why don't we start with the super resolution int4 demo, if you can pull that off. And I think we can get it running. Folks, this is live. It's not Memorex. I think we can get this running and live so that Joseph can actually talk a little bit over it and tell us what we're seeing.
All right.
So go for it, Joe. Yeah.
Yeah. Okay. So what we have is gaming content that's running through our super resolution network. We call it QSRNet. And what it is a deep learning solution that's been trained to upsample this kind of content. And it's something that can run very fast. And it's an example of focusing on the domain, having a smaller model, being able to run it fast. And this is also even further quantized to int4. Now, I'm actually running it with a cap on the frame per second, just so that you can see things. This is like the natural speed of movement. So you can kind of see things that are going on, and I can pause it, and you can see the left side can be more jagged than the right side. It can be more aliasing going on with the background. Let see if I can catch something here.
Textures aren't quite as sharp on
Yeah.
the left.
Yeah, and then I think earlier there was a flame, and the flames themselves also weren't rendered as accurately. So this is something of an example where, if we have a certain content, we can make it run really well. Now, what we can even do further when we move to integer network and even int4 is we can see how fast we can run it, and this is where we have this other mode where it looks like it's fast forward, but it's actually more about running it as fast as possible, as the processor will allow us. And so here we have the frame per second on the top right corner is almost like 140 sustained, and that's even though we're zooming in on a crop. The left says like a 137 by 137 crop. This output is doing the whole rendering, so we are getting a 4K image coming out, and in the process
from a 540p input.
Yeah, from a 540p input. So the processor is going through all the work to do it, and it's still getting it 142 frames per second. Meanwhile, we're zooming in, so you can take a look and see the differences between the left and the right.
So this we saw something from Qualcomm earlier, I guess, let's say about a month ago, I think, called Snapdragon GSR, which is different. This is an algorithmic implementation of super resolution. So very much similar to, let's say, DLSS from NVIDIA or what have you for, PC gaming. This is similar in its algorithmic processing and, integer 4 precision is what you're actually showcasing here, right?
Yeah, the algorithm behind it might be a little different than some of the other ones from other companies.
Oh, yeah.
But I would say that, even relative to what you mentioned at Snapdragon Summit, this is more of like an AI research demo showing that you can run a neural network based a super resolution algorithm and get it up to this resolution and this speed. Because I think at the time when we kind of started this project, it was kind of in question, and we wanted to demonstrate that these techniques are really really amazing, but they're also something that we can potentially bring to the edge one day, from the research and the papers and so forth. So this is where so that's where the point of this is. But and then we take it a step further with Infor. Like even last year, we did even show this with, say, natural image and in 8, but then we pushed it even further and went down to 4-bit. What the difference, not just in speed, but like for going down to 4-bit, more the benefit was that it's hard to see it now, but we had a power measurement too, and we were getting like a better power draw when running these, because this is super resolution. It's running every frame, and it's running at if I run it at the max rate that's allowable, it's running it's running 142 frames per second. So you can imagine that if we can spend a lot less power on that, that's a big deal.
Sure. Yeah. Very cool. Very cool. Marco, did we have any questions that came in that we should field now, or should we move on to another demo?
It's a slight shift, and it might not be Joseph's purview, but some of the earlier questions that were rolling in were asking about the Windows on ARM, the Snapdragon processors in the always connected PCs, and do they have similar AI capabilities to what's currently in smartphones?
Good question.
Yeah, that's really a product question. I think so. Fairly, you can see how like on past platforms we have had, they're very publicly sharing that we have an AI engine, and we are like one chip, one platform. We can go adjacent. We can go to IoT, compute, mobile. So that's certainly a strategy that we have. More specifics, probably good to kind of bring a product person on and talk about that. But certainly
Sure.
want good capability on all of our devices.
Similar
Got it.
engines. Sure. Sure. This is an interesting one, and I think this is probably in your wheelhouse, Joseph.
Sure.
Little bit off the path from where we are right now, but what the heck? Tim Podiddy Sweezy from the audience asks, with leaps and advancements in AI recently, has Qualcomm begun investing more in researching how to use it ethically and responsibly? Now, these demos you've shown here are, media entertainment and, less involved with ethics, but any thoughts there? And I guess, sort of what you're sensitized to, in your role.
Yeah, I mean, it's a great question. I think it comes up even more when generative AI is coming into play. But this is a question that's been around even back when AI was optimized for camera, and like, was there bias in that and so forth. I would say that, well, so Qualcomm as a company is of course tracking and aware and making sure that we understand what's going on with things happening in the EU, for instance, on AI Act and so forth. It is important to know, where is our responsibility in this. At some level, because Qualcomm as it stands, we do have a platform, and then it's up to people to use it responsibly. But then it's also, we have applications. Even from a research standpoint, we have to be careful. What do we demonstrate? We want to make sure that we are, also careful as to the content that we're showing legally. Is it make does it make sense, and does it make the point across that we want? Because we're very excited about the technology, but we also don't want to be irresponsible on promoting it. So.
Yeah, makes sense. Very cool. Should we, Marco, do you have another series of questions in there, or should we move to another demo?
We do, but I think that's a good segue for the other demo, because generative
Oh, yeah.
generative AI, it's top of mind for everybody right now. For us, we I'm just going to go on a mini rant. I hope I don't get anybody in trouble here. Like Chat GPT's popularity, I have serious reservations, because it's trained on content like we've produced, and it spits out content for its users that perhaps is plagiarizing from us. And that's one of those areas that we'll have to navigate. And I think the generative AI is because it's top of mind, and it's one of those issues that has everybody's imagination going. I think let's show the demo and show the kind of cool art that can be created using AI, and let's see where the discussion goes from there.
All right,
Yeah.
sure. So I'll give you some background. One of the amazing things with generative AI these last couple of years is that the atmosphere of the companies doing the research, and companies and institutes and centers doing the research, is that they put a lot of open source models out there for people to try things out. So one of them was Stable Diffusion, and the goal of this demonstration was more about, can we take a generative AI model that's been open sourced and deploy it virtually as it was released? So can we keep the accuracy and the as much as possible from the original model that was deployed? And so here we have this is our interface. You can see that I can type in words to be generated, and we also have kind of a history. So just to make things easier, I'll put in a pre-typed prompt, because this would take me a while to type that one. But it's great. It's the way the model has been trained. It's amazing technology behind this. It will do its best to follow this with certain guidance that's also in the settings. And then we go and generate from this. So we're wanting to generate a Japanese garden. And what's happening is the network is taking this text, generating an embedding, and then it's going through steps to denoise this into a perceptually pleasing pixel level picture that is 512 by 512 on my screen. So you can see here's that Japanese garden that was asked to be rendered. And it's pretty amazing. This was, we also have this in airplane mode just to show people that we didn't go off the internet and send this to the cloud. We can take this other fun one that we like as our kind of de facto mascot.
That was 13 seconds to render that bit of artistry. Unbelievable, actually.
Yeah, it's amazing how much it, because every pixel has some like meaning to it. So it's every little detail is there, and it's rendered all of that. I mean, it's not like a sketch or anything like that. It's actually fully rendered image. The photorealistic prompts are the ones that tend to be quite amazing.
Yeah, you've got you had V-Ray rendering, so you're talking about light sourcing in that case, and
Yeah.
so you can literally you can describe I guess effects as well as the composition of the image. That's pretty cool.
Yeah, and it'll do its best to kind of match that, because it's funny if we say 4K, it is a 512 by 512 image, so it's not going to really necessarily go to 4K, but there is a kind of understanding that 4K means photorealistic,
Precision.
precision, and so that's what you end up getting.
Yeah,
I think an important distinction with this demo that you're seeing right now, this is running on the local device, and it's able to perform this quickly due to the work that Qualcomm AI Research put in to optimize this model for mobile use cases. Like normally Stable Diffusion runs on big servers or big hundreds of watts GPUs. This is running on a phone right now, and it's doing it in just a few seconds. That's a huge deal.
And I should say, we had a big part to play in this in Qualcomm AI Research, but the AI stack was like another significant contributor. And then just there's a hardware team behind all of this, that makes the AI engine. And all three of these coming together to do generative AI was we were so excited when we had it rendering. When it first came up back in February.
Can we feed it something and see if it gets close?
You'll have to deal with my typing, but certainly we can do that.
Marco, why don't you take a stab at it? I know you were doing some interesting stuff.
Well, we could let's do something super simple. Let's do like the Statue of Liberty at sunset. Just something.
Make it an ultra wide.
Ultra wide?
Like an ultra wide field of view.
Oh.
It will always come out as 512 by 512, but I can put ultra wide if you want.
Yeah, not the aspect ratio, but just like if you had a very wide angle lens.
Oh.
Is at least my idea. We'll see how it interprets it.
Yeah, we'll see what it says. Maybe at sunset.
Yeah, that's perfect.
Yeah, sorry, my typing is. Well, let's see what it gives us.
Yeah.
See, this is like we could probably kill an hour discussing.
I know. Just playing with it. Yeah.
Like just like for us at Hot Hardware.
Wow, look at
that. That's amazing. We're constantly looking for feature images for an article or a thumbnail for an article, and publishing online, you have to worry about copyright and this and that. This would save us so much time in searching for images. Just bang, just go generate an image for your feature. It's really cool.
There's a lot of times where we have a topic that it's just like some nebulous concept really that we're writing about, and it's really hard to go out and even find a stock photo, if one exists, that really captures the essence of what you want.
What are the copyright implications on generated content? It's not copyrightable, correct? Is that?
I think those are the roads we'll have to navigate in the years ahead.
Yeah, unfortunately, I don't know those yet, but I know someone I could bring next time if you want to know the data thing.
Good stuff for sure.
So we've got Ziv Zoolander asking here the thermal management, or I guess the thermal implications of running this workload on the phone. Is it getting hot? Does performance slow down, or does it handle it fairly well?
Yeah, good question. I believe it handles it fairly well. We didn't have any overheating or so. So this is kind of secondhand information. I remember hearing that when it went to MWC, it was just being shown constantly. Like everyone wants to see something. They have their own pet rendering that they want to do.
Yeah.
And we just would, be here in San Diego on the sideline, just checking blogs and seeing what people relayed to us. But we never heard of anything saying that it was getting hot or we had to shut it down or put it aside.
I'll point out that it's still rendering at about 13 seconds here, and we've done quite a few of these in quick succession. So it doesn't
Yeah.
seem like the performance is waning over time at all.
No. Good stuff.
So we just had one more question pop in, and if from Nevin, I might just reframe it slightly because it's more of a product question, but I think Joseph can riff on this. So Nevin's asking, he says, I have a question regarding AI in general and specifically about super resolution. Will you also focus on the lower to mid-range device segment? So I assume, I know right now the demo that you showed, that's not in the wild. This is just a research effort at Qualcomm for now.
Yeah, that's
But
right.
could it be used? It's not just for flagship devices, correct?
No, we so these models, these larger ones like Stable Diffusion, it's better to run them on the flagship. I don't think we ever tried to run them on a mid-tier or so, even within Qualcomm Snapdragon. But I should say, like, the question looked like it was also wondering about super resolution and maybe there's various other models that person is interested in. If you go to AMET has a presence on GitHub, and there's a models view there. You can see that we have a variation of models that have been kind of optimized for deployment, and it's just a matter of deploying those on mid-tier phones and trying them out. There's no reason that I don't know the stats on all the phones in our product line, unfortunately, but I do know that if we're optimizing a model, it's just going to make it easier to become on mid-tier because that's something that's always going to benefit.
Yeah, makes sense. I think that probably wraps up the questions we have. I've got one more sort of, personal for Joseph, but Marco, anything else that I may have missed in the meantime?
No, I think we covered, like, there were some questions in the chat that were all kind of adjacent to each other. So I think we are clean there. We covered, different types of math. I think we're good. Why don't you go to Tim?
Well, I think you and I both came up with this one, and it's really sort of we would like to get a view into what gets you up in the morning, Joseph. So what's the most intriguing, exciting thing for you? Perhaps the most interesting opportunity with respect to machine learning and AI on the intelligent edge. What gets you up in the morning? What gets you caffeinated? What's really exciting to you? Because obviously this is a fascinating field. It's evolving, literally in front of our eyes, and it's just really cool research. So I just wanted to hear what really excites you.
Yeah, I know. It's a great question. What also, like, what keeps me from sleeping? Not just gets me up in the morning. What keeps me from sleeping at night? Yeah. So, at some level, it's even like before I came into AI, just like coming to the company. There's a lot of great people to work with, like smarter than me, for sure. And that coupled with wanting to support research with the company, and then a company that knows how to scale. Like if we show them something motivating, they'll double down on it and they'll scale it. And it'll be in my hand one day, or it'll be on my laptop one day, or it'll be in my car one day, or in my home, or whatever. Because that, like, Qualcomm has that kind of reach, and the research and the R&D and that whole pipeline of thinking about how we can put it in the system has been a great culture that AI is like taking it up to another level when I moved over, because I've just been amazed at how much more is to be done and can be done. And then this move into generative is really a kind of a fun one, because I look back, and at some point, even before with simpler networks, people were kind of curious: should it run on the edge? What's the benefit? It's not just can it run, but is it beneficial to me for me to run it on the edge? And we kind of went through that exercise, and in a lot of cases, people are pretty convinced. Oh yeah, you should have AI at the edge for various things. Like I'm a camera, I feel like if I don't have it on the camera, then it's like not a better camera. Now we're going through the same exercise, I feel, with generative AI. Like the questions are now, can you run it on the edge? Okay, now that you can run on the edge, is it better to run on the edge? And we're going through this, and we had a series of white papers on generative AI, hybrid AI, like these certain concepts that I invite people to kind of read afterward, because it's going to this position where, yeah, it's really, there's a lot to do still. And it's going to be even better than, there's cloud. Cloud has done some amazing things. Edge, you can move things to edge, but if you design the synergy right between working with capable devices, working in the cloud, there might be some things that you can do even better than if you were, completely encapsulating on one side or partitioning. And this is where there's, a long road ahead, which we like to think, but AI moves so fast that it could just be done in 3 months. Who knows? But that's where we are, and that's what's keeping me and the entire group excited.
Are we at the singularity?
There's that kind of excitement too, which I'm an optimistic person, so
I think you're right. Yeah. Hey, Joseph, thank you so much for your time. Qualcomm's Senior Director of AI Research, Dr. Joseph Sorriaga. You said there's smarter people at the company than you, but you're a doctor and you seem like a pretty smart guy in this field. So thanks so much for humoring us.
Yeah, I'm glad to be able to just, I'm glad you welcome nerdiness, and we can get down to these different terms, and it's a great conversation. So thanks a lot, guys.
Absolutely. Yeah, no, the name of the live stream is 2.5 Geeks. I think we probably, you must equate to like a 5X geek or something like that, in terms of geek cred. So no, great stuff, Joseph. It's been a pleasure. Any parting words, Marco, Chris, before we let Joseph off the hot seat?
No, I'm good. Like, again, I love hearing talks like this, because it gets your mind wandering about all the possibilities. Qualcomm's in a unique position where they have, as we move towards ubiquitous computing, and Qualcomm's already got chips in almost everybody's pocket, and they're in the data center, and they're in a unique position to kind of wrap all this together. So we could probably talk with Joseph for hours, but I know we got to let him go.
Yeah, we wouldn't be talking. We'd just be putting more prompts in, probably.
There you go.
Generating stuff. Yeah. Hey, Joseph, thanks so much for your time. We appreciate it. I know your time is valuable, and it's been a fascinating discussion, and we'll have you back on anytime you like. It was a pleasure.
Yeah, same here. Thank you very much, guys.
Right on. Well, in that, we will bid you adieu. You can find us on the web at hothardware.com, twitter.com/hothardware, youtube.com/hothardware. We're everywhere. And hit thumbs up and subscribe so that you can catch the live streams when we bring on fascinating people like Joseph here from Qualcomm to join us. And in the meantime, we'll thank you very much for stopping by.